Girls and gals and friends and family, and we just appreciate your time today. I'm coming from Western Oklahoma. It is a little bit stormy out here today, and hope that you and your family are doing well during this time. So today, just like Elaine said, we're going to talk about the inverter system, the 2.0. A little bit of differentials between the 1 and the 2, but we're going to hopefully examine the 2.0 and break it down a little bit. Hopefully that some of this information not only will be new to you, but also maybe strike up some conversations or some questions as we go through this. So sit back, have a good time. I think that when we're done with this, Elaine has your email address, and we will be sending this out to you. So again, here we go. This is how we used to do our training before everything kind of broke loose and we all had to come inside and be away from each other. So this is our training trailer that we brought around to you. And if you've seen this, awesome. If not, this is what it looks like. Just want to show you a couple of things that on this trailer that we're probably not going to talk about in depth, but it is over on the left-hand side, and it is the air handler. Brand new BVA multi-position air handler. If you need to put it to the downflow unit, you just take the cover off, take the coil out, flip the box, put the coil back in, put the cover back on. So there's no downflow kit for you to have. Several things that are different inside that particular 2.0 from the 1.0 is that it has a code blow, an anti-code blow device on it. So when my heat pump turns on in the wintertime, we don't get that automatic fan coming on with the air handler. We're going to wait. We're going to delay that fan until that coil heats up, and then we're going to be able to turn that fan on. So that's a really nice brand new feature. Another feature that we have is actually a 2-speed blower board now, so that when we want to downgrade the blower in a what we would call a Y1 situation, it does that. Y2, we speed up the fan motor. And we'll do that both wintertime, summertime mode type scenario. A little bit of different transformer. We got a multi-tap transformer now. We have a fuse that is like your car fuse that's on the board at that particular time. So one more thing about the air handler before we get over to the other part is that you notice that this air handler has a all aluminum coil. So this coil is based off of the design of our cased coils, in that it does have a TXV valve, but it is all aluminum, no more copper tubing, aluminum fin type coil that the BVA1 has. So let's move over to the right, take a look at the condensing unit. This is the 3-ton condensing unit that James has in his trailer down in the Texas area. And you see that we've got some green lights on this particular unit. This means that the unit is got electric to it, it's ready to go, and it's actually running. So the 57 represents that it is running, and it's got 57 hertz through it. So if you're familiar with the 1.0, you would notice real quickly that the green LED lights on the 1.0 now are red. So hopefully you will be able to see that more easily in the direct sun. If you're familiar with Bosch at all, you know that we've got the BOVA on the left-hand side. We've got a case coil. We got the BGH 96 gas furnace, and we also have the BCC 100 as far as a controller and a thermostat, and its little brother, the BC 50. And so that's a family of products that we have available at this point in time. Not pictured is our brand new IDP, which is the package unit. So this is our trailer. This is what we're going to talk about today. When we went from the 1.0 to the 2.0, we didn't change any dimensions. We're still basically at the 29 left and right, front and back scenario. Didn't change any of the height, so everybody was very happy about that. But what we did change is the BOVA 60 on the 2.0 is no longer like this particular application in that the 1.0 has two boards, on the 5-ton unit with the bridge rectifier being in the middle. Now the BOVA 60 2.0 just has one board. So that was a big change, along with some other other items, but that's the biggest change that you'll see between the 5-ton units is the board being one board on the 2.0. So let's talk about high voltage. A little bit of change here. 280 or 186 to 256 was the low and high on the 1.0. Now we're looking at 172 and 270. So somewhere between those particular voltage, again, this is a single phase product. So somewhere in between those voltages, we're going to make this system work. I tell people all the time that this board is a brain. And so as we start to drop toward that 172, this system will actually deregulate itself. If it's a 3-ton or if it's a 5-ton, you're not going to get 36,000 BTUs of capacity or 60,000 BTUs of capacity out of it. It will start to deregulate itself, trying to push BTUs to the structure or remove BTUs to the structure. But it will not burn itself up. Will deregulate itself, taking the compressor down in hertz ratings as we get toward that 172. Hooking it up on the bottom left-hand side, L1, L2. This is my board inside the unit. We know that we had those lights. Those lights mean something. You call me on a Friday afternoon, we're going to talk about those green lights, because the green light on the left-hand side is my green light showing me power. So that particular light will either flash or it will be solid. It tells me that we have L1 and L2, but we're also in a standby mode. The standby mode is nothing more than maybe we have disconnected the power, brought the power back on, and we're waiting for that particular 5.5 minutes on the 2.0 unit to regain what we need to have to make this system work. So again, standby or on, LED to the red light. So if that red light's ever flashing, that means we have a fault situation going on and we need to start looking at the issue behind that. And the green light over there is either powered on or powered off. So if we do not have the power on the right-hand side, we're not going to have a green light. There they are. So when we're talking about the L1 and L2, we always have to bring up the ground. This particular machine has to be grounded properly. It has to have a proper ground. Just because it is green going back into the box, it doesn't necessarily mean that it's properly grounded. It has to make sure that we have that grounding rod all the way back into the earth ground, making sure that the DC power of that board knows which direction to go into. So we've asked people in the past, and I understand that this may be getting into some situations where we're looking at a different licensing from a mechanical license back to electrical license now, but the machine has to be grounded. If not, we're going to have issues with the board. The machine is not going to work properly. So we're always constantly looking at the earth ground. The next thing is you're not going to see this in the IOM, but you'll always hear it in training purposes, and it's a surge protection device. Don't really care what brand, but that board on my unit has to and needs to be protected. Somebody says, well, Fred, how come you don't just put it into the machine? Just not happening at this point in time. So we're asking you to install one of a surge protection type device. Some devices are maybe more economical than others. Some devices may do more things than just be a one and done type scenario. But if we've got our house and it is being electrified by a whole house generator, that particular machine may have a whole house type surge protector on it. That's going to be okay. But when we're looking at a pull start type generator, really need to make sure that we have a surge protector. Always ask me, well, Fred, what happens if the system goes bad and we do not have a surge protector? And now, still going to have the 10-year warranty, all of that kind of thing. Just going to, again, highly recommended. Side of my board is the CM3 plug. That plug goes up to the, and is basically the Molex plug for the 10-speed condenser fan motor. Now, the 10-speed condenser fan motor is on the 3-ton and the 5-ton. So the 3-ton 1.0 was a 2-speed PSC motor. The condenser fan motor on the 1.0 5-ton was an 8-speed, but today on the 2.0 units, they are both 10-speed condenser fan motors. One of the issues behind this board is that if I turn the power on, electrified the board, and then I wanted to do something, change the board, do something with it, check something, may want to turn the power off, pull the disconnect. That screen up there is going to go black, but that doesn't necessarily mean that those brown DC capacitors have dissipated their voltage that they can hold for a while. There's nothing on the board to dissipate that voltage. You can't take a screwdriver like my dad used to do and short across the board to dissipate the voltage. You just have to wait a little bit. But there is a connection part up here that allows me to look at points P and N. And when I look at those, what I'm looking for is less than 42 DC volts. So I'm going to put my voltmeter on DC, and I'm going to insert them into the points Paul and Nancy, and I'm looking for less than 42 DC volts. If I have less than that, then I am safely able to go into the board. If not, just wait a little bit longer. It's not a long period of time, but just wait a little bit longer and then check it again before we want to go in there. That is your safety points. The safety points are also on the 1.0 unit. P2 and P4 are on both the 3-ton and the 5-ton, and it's the same scenario there. We're still looking for less than 42. So up on the screen, you see the what we would call the dip switches and the push buttons and things up there on the top of the board. What we're going to be looking at here, guys, is going through each one of these to see where they're located, and not only where they're located, but what their function is. SW1 is my brand new 2.0 coming to you very soon Wi-Fi switch. Wi-Fi switch is going to allow you to push the button and enable this board to Bluetooth talk to you, basically maybe get all of its information, maybe the model number, serial number, maybe at the fault codes, maybe some of the themistors and what's going on, been able to read those values of those things and not necessarily get something like that. So I have my phone on silent, but any time that my favorites want to call me, they go ahead and get through that. Sorry about that. So the SW1 is that particular switch. 4, similar to the, but it has a little bit of differential in that I get to use this board for the IDP, which is a package unit. This particular system on the 2.0, I get to separate my condensing unit from the air handler, whether it's yours or mine, or whether it's a case coil, whether it's yours or mine. But I get to separate those via refrigerant lines, and I get to stretch them to 150 feet. So the 1.0 was 100 feet. Now I get to move those to 150 feet. But the board is the same from this unit, split system, to the IDP unit. So we have to make sure that we have some different logics behind that. And so in that particular logic, SW41 is going to have some characteristics to it that basically make this unit as a split system and not necessarily the package unit. So SW41 IOM says that it's going to come to you SW41 in the off position, SW42 in the off position. They need to be there. If we, for some reason, manipulate them and turn them on, the values of what we're looking at in this board is going to be different, and the board is not going to react the way it's going to be favorable for us because we're a split system. Anytime you manipulate one of these switches, you're needing to turn the power off, manipulate the switch, turn the power back on. When you turn the power back on, in this particular case, there's going to be about a 5.5 minute time delay before the unit actually comes up and operates the way that you want it. SW43 is the same exact type switch that was on the 1.0. If you're familiar with that, you're looking at what the book calls adaptive capacity. What we're looking at here is I think the easiest way to tell people is that the numbers that we're fixing to choose on SW44, there's a range there. SW43, if we are looking at a shotgun type pattern on a cardboard, we're looking at that number that we're wanting to hit, and it's a shotgun approach. There may be overshoot, there may be undershoot. That's SW43. SW43 is automatically turned on when the system is being installed. Your has been installed in some type of a zoning package, some type of a situation, maybe a high velocity type system. SW43 is in the on position. So if we wanted those numbers on SW44 to be a bullseye and we didn't want any overshoot, undershoot, SW43 would be turned on. SW44 is this, normal capacity, normal cooling and heating. Normal means 47 degrees logic on the summertime, 107 degree logic as a heat pump in the wintertime. That's the default. If I wanted to change that, turn the power off, turn the power back on, change the default in the summertime from 47 to 40, change the 107 to 114. If you read a little bit farther down into the book in the IOM, you would actually see that may be called enhanced comfort. One of the things that we have seen, if I lower the coil logic, my system may not run as long as I want it to, and we may have some humidity issues at that point in time because I am what we would call short cycling the air conditioning cycle and not making water like I should. So SW44 is a little bit different on the 2.0. In the logic, we go from 47 to 42 and not 37. Okay, so that's the SW44. Nothing more. SW5 has 2 switches to it. Again, if we're in a normal situation, we're going to leave these switches in the off position. If we're getting into a situation where we're putting this in a heat pump mode and we're down by a lake or we've got a lot of humidity, we might want to reduce that operation time of the normal run time. We might want to take 10% off of that. That's SW51. If we wanted to leave it on while it's in defrost, that is SW52. One of the things that I like to bring up in the defrost mechanism is that my system, the reversing valve is a B operated reversing valve. That means that I am energized in the heat mode, not the cooling mode. And so when I go into defrost, I am going to de-energize the reversing valve and then, of course, now be in the air conditioning mode. So one of the neatest things about this is that I never energize the reversing valve in a high Hertz rating or a high velocity compressor situation. When I go into defrost, I will always downgrade, deregulate the compressor, switch it in a very unpressurized type situation. To me, your neighbors will never hear this going defrost. We go back up into the Hertz rating. We're done with it. We want to terminate the defrost. We basically regulate the compressor, go back down, switch it again, that kind of scenario. Really neat logic behind the reversing valve type scenario. The other thing about the defrost system is that if I am in a situation that in a normal heat pump, and I satisfy the thermostat by the tempered heat that's coming out of the ductwork, a lot of your heat pumps would go ahead and just shut down because we lost the Y call. My system will actually finish the defrost just because we started it. We're going to finish it. And once we're done with that, then we're back in a normal operation. It will not shut off just because we lose the Y call from the thermostat. Very, very, to me, it's a very neat situation, neat logic behind the defrost. J2 switch is nothing more than a capacity switch. It is a switch that allows me to deregulate my 3-ton to a 2-ton, allows me to deregulate my 5-ton to a 4-ton, what we would call just taking the top end off of this system and that kind of thing. For 3.5 years, we've told people to leave this switch alone, allow this machine to deregulate itself. On the 1.0, we looked at a 3-ton working its way down all the way to a 9,000. That's not the case with the 2-ton. The 2.0. The 2.0 goes to about and can deregulate itself to about a 14.6. So what would that be? A little bit over a ton of capacity, not the 9,000 that we saw. The other side of that is that the 5-ton 1.0 went all the way down toward a 2-ton system. The 2.0 5-ton system goes down toward and in between the 2.5-ton and 3-ton. So a little bit of differential in the lowest denominator of its capacity with the J2. But again, I think all of the trainers agree with in saying that the J2 switch, leave it a 3-ton, leave it a 5-ton, leave it alone. The SW2 button is nothing more than the force button. The force button allows us to do something to this machine upon our demand. I can allow the unit to run in the air conditioning mode, push the force button, and I allow the machine sees what I've done, and it will ramp up itself or deramp itself down toward and get to that 100%. So when we say this is a 20.5 SEER rated unit, it was at 100% capacity when it achieved that number. So anytime I am in less than 100% capacity, I'm a greater SEER rating, I'm a greater EER rating, I'm using less watts than what happened at the 100% level. This machine will go by itself up into the over 100 toward the 110% capacity range. If I wanted to make it, whether it was running in the heat mode or the cool mode, and I wanted to make it go into a 100% range, I could push the force button and then it would automatically do that. It's going to stay there for 2 hours, or if I get through with what I need to, if I'm doing refrigeration calculations and things like that, push it again, it goes right back in the normal operation. If for some reason I lose the Y call, if I satisfy the thermostat, it goes back in the normal operation. You'll see here in just a second that if I'm in the heat mode and I've allowed my system to run what the book called 20 minutes, and I was able to push this button for more than 6 to 8 seconds, I'm actually going to be able to force it into a defrost. So this page right here shows you what happens when I push the button and make it into the force mode. If my system is a 2-ton and I'm in the air conditioning mode, I am going to be at 48 hertz. If I'm a 3-ton system and I push the button, it's going to be 72 hertz. And the same with 4-ton and the same with the 5-ton. That's the air conditioning mode. If I'm in the heat mode, there's the 48, there's the 72 3-ton, there's the 54 4-ton, and the 62, which is the 5-ton system. So that is the 100% scenario. If you look down here at the bottom of the slide, you'll see 110% air conditioning mode, and then we have a little bit of differential between the 1.0 and the 2.0 numbers here, that if my outdoor ambient temperature is above 28, I'm in the heat mode. There are my numbers 70, 86, 70, and 80 at the above 100% scenario. And then if my outdoor temperature is below 28, then there are the numbers to the right. So again, Force button pushes, gives me 100%. And that is a logic machine scenario. I made the machine do that. I can't force it in to do it 110% by itself. It's just going to do that on its own. So the J2 was a capacity switch. We saw that. Question. What happens if you're sitting the unit on a Friday afternoon and you're sitting a 3-ton unit and you've got a 3-ton indoor unit and you're ready to do some calculation on it, subcooling, and you push the force button, and when you it goes into force mode and it comes up to 48 on the Hertz rating. It's staying right here. Nothing wrong with the board. I would bet you that somebody pushed in the J2 button. Maybe they don't work for you anymore. And you've got a 2-ton unit. No big deal. Turn the power off, flip the J2, turn the power back on, wait to 5.5 minutes, allow it to come back on, and you're probably going to see 72 as a 100% button at the same time, at that time. The SW2 force button, we're going to push it now. We're going to make it go into defrost. Several things that allows our system to go into defrost. You're going to take about 35 seconds probably for you to see that DF on your display. But your outside fan will stop, your reversing valve will de-energize and will be in the air conditioning mode. It will complete its defrost scenario even though you pushed it. You don't have to push it again to get it out of defrost. It'll come back out of defrost when it's ready to. And number 3, my favorite button. I tell people all the time, this is not this not my dad's unit, this is not my grandpa's unit type scenario, but this button allows me to look at what's going on, whether the system is running or whether the system is not. The 1.0 parameters was about 17 on a chart. There was about 17 parameters that I could sit on a bucket and find the numbers for. The 2.0, there's about 25. So we've added some parameters to this button, to my unit, literally leaving the voltmeter in the truck, literally leaving the gauges in the truck from here on out on the 2.0. This is what it looks like on your IOM. What it's going to have in front of you now, these parameters over here on the left-hand side, I get to push this unit. I get to push that button, and when I push the button, it's going to show me what J2 is located at. It's going to say H3. It's going to say H4. Whatever it may be, whatever the J2, that's what it's going to show me. The other thing is push it one more time, and I get a 0-1. When I get a 0-1, that is going to be my call coming from my thermostat. It may be 0. I may not have a call. I may not, that thermostat may be in a time delay at this point in time, but it's going to show me what I am getting at that particular scenario. So it's a 0 or it's a 2 in cooling, it's a 3 in heating. There are my parameters type scenario. So very, very nice, very, very good logic to show you what's going on. Whoops, I did not mean to do that. Let's go back. So these are the parameters, and let me just kind of show you what a little bit of difference between the 1.0 and the 2.0. The 1.0 had the T3. That T3 was my coil temperature. T3 is located on the liquid line about 3 rows up, and it is giving me a liquid line temperature number. The only thing that you needed on the 1.0 was to have a liquid line thermistor clamp type thermometer to get subcooling readings. Today on the 2.0, you do not need that anymore because we have number 7. Number 7 is the T3L. The T3L is located right behind the case, right behind the service valve on the liquid line, and it allows me to see that liquid line temperature. And now I can take the the temperature that's coming from my head pressure. I get to look at this T3L, and I get to do subcooling. So again, leave the gauges in the truck. On the rest of the page, I'm looking here from parameters 10 to 25. You can see that I have some new ones on here. If you looked at number 18 is my fan speed. On this particular one, it would be one of 10 numbers. If I had the 1.0 3-ton unit, it's going to be one of 2 numbers. That's a 4 or an 8, low speed, high speed. If I had a 1.0 5-ton unit, it's going to be one of 8 numbers. There's your 8-speed ECM motor. But on the 2.0, 3-ton and 5-ton, it's going to be one of 10 numbers. Number 20 is a brand new input parameter. I get to see now my voltage coming into my machine, my L1 and L2. I get to see my compressor voltage that we have now on, coming in from the board to the compressor. I get to see the continuous runtime, number 22. And again, I get my last fault code. Last fault code is not going to be diminished if I lose power. It is going to stay there even if I lose power and have it gone for a day or so and bring back the power. It's going to be there. If I get through with a fault, I can't clear that, by the way. So this is a piece of document that you're going to receive. Over here on the left-hand side of this document, to write down some numbers. And those numbers represent what's going on inside this machine. You're looking at the coil temperature, looking at the Hertz rating, you're looking at the liquid line temperature, looking at the evaporation pressure of the indoor unit, the outdoor unit, your target, that SW44 number, that's what number 11 is looking at. Then you look at number 12, that's what's going on inside the coil. Again, I'm looking at all of these parameters by just literally pushing a button, and I'm capable now of writing these parameters down on that sheet so that I can not only see, document, have a commissioning sheet, but a lot of times we've seen people using this in the last 2.5 months that they literally fix their problem, their issue, by just writing it down and getting it in front of them. Not making that very, very fast phone call at the end of the afternoon on a Friday. Again, head pressure. This particular unit, we're looking at a 375. We're looking at the PT chart at 375. Number 14 was 104. T3L is number 7. That's 104. Redo that. 104 and 112 is looking at 8 degrees of subcooling. So my math may be wrong on this particular chart. I just now saw that. But that is what the chart is for. That is what allows you to take your subcooling readings from the actual unit to the PT chart and putting it down so that you can see what this particular machine is doing. There are your numbers. We looked at the unit, and you're familiar with the unit. You're looking at 4 wires coming out to the outside unit to make me a heat pump. But we also take a look at how do I communicate. I communicate through the refrigeration circuit. I look at a pressure transducer that's inside the machine. But I tell people all the time, we're a very critically charged piece of equipment, and being critically charged, that's how I communicate. So we're looking at number 1, a total length of line set, just to measure that 3/8 liquid line. Give me a linear footage out there. Don't care about elbows or dryers or anything like that. Put that number down. If you're putting the unit in a situation where we are looking at less than 15 foot of line set, leave the refrigerant calculation out. You're just going to pull 350 micron vacuum, open up the suction side service valve first, and basically what we would call dump the charge. But this particular machine, again, critically charged. So you take the 15 that we give you, you take number 3, and you're going to multiply number 3 into and by number 4. So we're looking at 0.6 ounces per linear foot. Weigh that in with a very good weighing scale. We're not sweat bag type situation. We need a precise measurement of refrigerant going into this machine. So when we're looking at the fault codes, a lot of the fault codes are the same from the 1.0 to the 2.0. Somebody asked me the other day, well, Fred, what's the number 1 fault code that you have? It's down here at ATL. My machine, this 2.0 machine, is an air conditioner down to 15 degrees. It's a heat pump all the way up to 86 degrees. It's a heat pump down to -4. It's an air conditioner all the way up to right around 122, 125 degrees. So got some really large ranges to it. But if we get outside of that range for any particular thing, we're going to see an ATL fault code. My status codes. If I push that force button and I'm looking at a situation that I'm wanting to do my parameters, my subcooling and things, that top what I call the left-hand side of a capital H is going to show up. If for some reason I'm trying to run this machine and I am in a under voltage situation, you will see the U. It's kind of like that scenario that we talked about earlier today, in that I am needing 240 volts, but let's say we only have 195 volts to make this 3-ton unit run. It will give you what it can give you out of that 195, but when you get up there and you pull the cover, you will see a U, and then you'll probably see another type of a number situation on the Hertz rating. So that is basically a limited situation. The other thing that I always like to point out is that capital A. That capital A is a oil return. And actually what you're going to see is this A. I can't make that triangle A, but you're going to see this particular A. This A is the oil return, and it's a little bit different logic from the 1.0 to the 2.0. If I have a system that has been running for 2 hours, and we've seen this in our training carts and training units on the trailers and things, basically running as we do the training. 2 hours of constant run time and basically not satisfying the thermostat, I will go into oil return. Oil return will be basically for 5 minutes. If I don't satisfy the thermostat during that particular time, if I don't reach the temperatures that I need to see, I will continue that for another 5 minutes, but never more than 10. So 2 hours of continuous time, 8 hours of accumulative time. So if for some reason I haven't what we would call ramp up during that 8 hours of cumulative time, I will go into oil return. So we think that you're going to see more oil return scenarios when you get out there and open up the cover of the unit on the 2.0 more than you saw it on the 1.0. On the compressor, the same, the V, the U, and the W, same type of scenario there. Different compressor. This compressor is a GMCC compressor, George Mary Cat compressor. It is manufactured by the largest manufacturer of the compressors in the world. This compressor allows us to have some more BTUs in the wintertime, allows us to have a little bit greater sound situation, a little bit less type of thing, but it does ohm out different than the 1.0. So on the 2.0 unit, the 3-ton is going to ohm out basically greater than 1 ohm. And the 5-ton is going to ohm out. All three of those are going to be the same. It's ohming out like a 3-phase compressor. And those are going to ohm out less than 1.5 ohms. $10 years, no registration on the equipment, still the same. Labor allowance type thing. But if you want to grow your business, if you want to allow an additional 1 year to that 10 for Mrs. Jones in her structure, you're going to register this. You're going to be a part of the ABC program, and it's going to allow Mrs. Jones to have 11 years of part warranty and not just 10. So a lot of things that are going on at this point in time with us being quarantined in our home offices. A lot of things are coming through our e-academy and things like that. But if you want to take a look at that, there's some website things for that. Parts, spare parts, whether they are being in New Hampshire or in Illinois, we've got them readily available for you. Want to really thank you very much for your attendance, for being here with us. This number right here is our tech support line down in Fort Lauderdale. It's a great place to get some answers and for things and changing parts and that kind of thing if you need to do that. That 866-642-3198 number. Thank you very much.